Yes, I want to speak for a project we made about 50 years ago. You see, it's about the time to take it in the archive. Just a moment. I will speak about this project, which was a project made for the telegraph and the Swiss telegraph. And in the 60s, the Swiss telegraph was a very important service. Well, because it was the last system who had to work when everything else would not work anymore. If your phone had problem, if the other communication means didn't work, the telegraph had to work 7 days a week and 24 hours a day. You have telegram deposited. It was possible to deposit telegram everywhere. In all you have about 8 or 10 telegraphic offices in Switzerland, but you could deposit telegrams in the post office, and so you could even deposit telegram by phone. And the telegrams could go to about 100,000 places in Switzerland and in the world. It was possible to send a telegram from any place in Switzerland to a place somewhere in the world you don't know, and nobody knows where it is, but it was possible. In the beginning of the 60s, the management of the telegraph had the crazy idea. He wanted to use computer to help the telegraph to work. It was not especially to spare people. We had about 900 employees in the telegraph. It was much more the problem of the heavy load of the work for the telegraph people. And you have to see what telegraph was. Today, you have mails, you have a different way to send information from one place to the other. At that time, the telegraph was a quite important system, not only to send letters between two people or important, or would say, if somebody get married or something like this, but it was also important for the economy. And you have to see that telegram was not only something which was written, but if you send a telegram from one place to the other, you had to send it by phone lines or by electric lines. It was electric signals which were transformed from the text to electric signal, and so most of the place you remember before the 60s, the telegraph was done with the hand as the Morse alphabet, and so. And in the 60s, most of the time it was transmitted with teletypes, and so. But in some countries, they didn't have the teletypes. They still had the old ways to work. In the Swiss law, the telegraphic law was that the service has to be 100% service. On the other hand, in the 60s, computers were not quite safe machines. You have more problems with computer than you may attend, you may want. And the problem was what kind of solution will be possible to replace the service which should never fail. It was quite a big problem. The management of the telegraphic service hired 2 people in 1964, an engineer specialized in telecommunication, in fact, even more specialized, it was electric engineer, and software specialized, and I was the one for the software who was hired. But we had absolutely no idea of the telegraph. Okay, we knew what is telegraph. You can send a telegram from one place to the other, but that was the only information we had. And then we had to learn what it was. And both of us spent about 1 year to really learn how does the telegraph works. I spent about 1 year in different places of the in Switzerland to practically to learn as an apprenticeship of telegraphic personnel. We were both speaking French, which was much easier to work together. And the first problem was, how is it possible to have a system who runs for years without failure? You should remember that the computers to that time, they worked from time to time, but it was not very good security with them. And then we had a very long discussion until we came on the idea why does the planes or some kind of planes have 3 or 4 engines? It's a question of security. And the idea we had is, could we do the same with computers? Is it possible, instead of having just one computer, to have 3 more than one computer, 2, 3, 4 computers, so that the result will be exactly the same as with planes? And after long discussion and quite a time, we decided, yes, why not? We can try it. And we designed a theoretical solution. It is, you see, you have here, we have 3 computers with the memories and so on. And you had, by the computer, you have lines which come in, and you have lines who output lines. It was, by the incoming lines, it was quite easy to separate the electric signals on the 3 computer systems. But when the result has to go to the output, then we had 3 output lines for the same information. How could we manage this? Then we came to the idea, I will come back. You see here, we have the idea to have the 3 lines coming out of the computer, come back in a kind of mini microcomputer, and we gave a name to that. It was majority discriminator. So that when the same signal came in this little computer, if you have the 3 signals which were the same, then it went out. If you already have 2 identical, it went out, and if the signals were different, it was nothing. And of course, these discriminators has to be synchronized with the 3 computers. The 3 computers had to be very good, very well synchronized. It was a condition. You also have to see that telegraph signals are time dependent. It means the computers you have has to be real-time computers. And in the 60s, the real-time, you have practically no real-time computers. It was practically not on the market. And you have to see that this kind of solution was some kind a difficult idea. Not only for us, but also for the computer manufacturers. We have to, to be able to bring the solution, we have to have a system which never failed. And we make all the computing and so, and to come to the solution that the system we have designed before was able to work 16 years without failure. Okay, that was our idea. And then the question was, which supplier will be able to make such a system? And it is quite interesting. Before going to the tender as such, we asked some supplier, computer manufacturers, what do you think of this idea? And IBM came, the management of IBM in the States came to Bern, to the Swiss PTT, and said them, forgot this idea. It will never be possible. So you can do another way, but you can not solve this problem with computers. Okay, it was a situation. Another problem was, I think I have, no, that is how the telegram were at that time. It was wild documents written about and it worked well. It was going through people who were able to understand what was on the telegram. But to be able to have this solution, we had to find a standard format for that. And we designed a format and went to the CEPT. It is a Conférence Européenne des Postes et Télécommunications. We went then, and we presented a new format for the telegrams, and this new format was approved from this conference. So we could make the next step. And okay, it's just a new format, it's not very important, just to see in fact, the big difference with the normal telegram was that at the beginning of the telegram, you have to have the 4 letters ZC, ZC, and then, okay, the rest of the telegram, and at the end, you have to have these 4 letters N, 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 N. So it was possible with that for the machine to separate one telegram from another. Then we begin to design the specifications, and the specifications were more than 300 pages in French. And before coming here, I went to the, when we were yesterday in the PTT museum, and I asked the PTT archive if they still have the specifications, and I get them. Okay, I had them during a lot of years, but with the changing of one city to the other, and so it was went out. And then we sent this specification to 7 possible competitors. And we received offers from some of them, and you had, for instance, an offer which came from Philips, which was specialized for telephone systems and so on, and they wanted to do the system with half a computer, half a telephone central, and think it was something okay. Then we received another offer, which came from a Swiss supplier. It was Hasler, today it is Ascom, and this was the best offer. And this offer was so far in the future, it is more or less the technology we get today. But the big problem, they were not able to give a price and not able to give the time where they will be able to bring us with the system. And in the system, you see, we have today, for people who know something from the computers, we have SSD disks. That is complete static disk on chips. And they had such a kind of disk to offer, which came from, it was an American society, but it was, we had no right to speak of them. Well, it was high sensitive product from the army industry in the States. Okay, so it was not possible to use them, but it was wonderful. And at the end, we received practically the best offer, possible offer was from Sperry Univac. Then, okay, they sent us a very good offer, very good precise, and then we have to take about 2 years with specialized from Univac to precise every point of the specification, so that they would be able to program the system. And it was quite a big job to be able to make all these specifications so that the system could work. And at that point, it was end of '67, the two project managers, also my company, myself, we had to leave the PTT, and we gave the project to the next equipe, to the next team, and this team has to program the system. It was people from UNIVAC and people from the PTT who program the system, and another team has to make everything for the test. Well, to build such a system was, of course, was a big challenge, but it had to work without problem for the first moment. We were not able to cut the telegraph, said, okay, we begin with a new system, and you have failures, we have problems, and so that it was the problem for the next time. And this is, in fact, it's the configuration we had for this project. And the project began to work in '71, in May '71. From the first moment, it works completely well. It gave a reduction of about 300 employees out of 900. And I get information after, in the years, and so, and in '85, I get a report, and it was in Computer World, and they gave the availability from the system has been 99.94% during the 15 first years. Okay, so the goal have been reached. And it was probably the first computer system, failure-free computer system in the history. And an interesting thing, I found it much later. I went once in Houston, in the NASA. NASA is a history museum, and looking at the system of the museum, and so I read a page, and the NASA said they bought the system from the Swiss PTT, paid $500,000 to the Swiss PTT for that system, and they used it for the message transmission between satellites and the systems from the body. And I met a general, a US general, in also somewhere in the 90s. We spoke from the system, and he said to me, the US Army has also used this system. He took it from the NASA for his own purpose, for the purpose of the Army. And I said, yeah, but you didn't have paid anything. It said, no, well, NASA is part of the US government, like Army, so that's the same box. And I also spoke once in the same time with the president of Tandem Computers, which was the first one manufacturers who made computers, failure-free computers. And we spoke on this, and he said, they built the system while they had engineer from UNIVAC, who came from UNIVAC to them, and with that help, they built their own system. So that's an idea. And the last thing is, was a memory of one of the memory of the system. It's the capacity. You cannot read it, but the capacity of this memory was about the same capacity as the capacity of a floppy disk. And you see the difference between this capacity and between this little USB dongle, which has 128 gigabytes. It's about, you see the difference from the time, see 50 years in the history of the computer. Thank you.